All right, so for graphing, solutions occur where the graph crosses the x-axis. So remember, for everything with quadratics, all of these methods here we're always looking for where those x-intercepts are. So on this graph, the solutions appear at -3 and 2. All right, so now this is what we're going to be doing in our packet today. So it gives you the equation. So the first step is you're going to use the formula to find the axis of symmetry. So remember, the axis of symmetry is the x value of our vertex, and it's -b over 2a. So we need to figure out what our a and b value is from the equation. So looking at our equation, what does a equal? 2, and what does b equal? -4. So remember, a is in front of x squared, and your b is in front of your x value, -4. All right, now let's plug them into the formula. If it's -b, we have to put that negative and then parentheses, and then we're going to substitute the -4 for b. And then 2 times a, so 2 times 2, since a equals 2. I then solve the numerator. If it's negative, remember it's like a -1 on the outside, so what's -1 times -4? +4, and 2 times 2. And what is 4 divided by 4? 1. So x equals 1. So that would be your axis of symmetry, and it's the x value of our vertex. All right, so now that we know the x value, now we can find the y value. So we're going to go ahead and write this so you have this vocabulary. Evaluate equation, let x equal 1. So remember, evaluate is just saying substitute for the equation. So we're going to substitute for x equals 1. So we go back to the original equation up here, 2x squared minus 4x minus 5, and we're going to substitute x equals 1. So anywhere we see an x, put 1 in parentheses. Whoops, minus 5. All right, now we can solve for that, and the answer will be our y value. So here, I'm going to put a y equals in front of it. All right, so you can either put it all in your calculator or just follow order of operations. So PEMDAS, we would do exponents first. What's 1 squared? 1, and then 1 times 2. 2, and then -4 times 1. -4, and then just when you have all subtraction, just solve in order from left to right. So what's 2 minus 4? -2, and -2 minus 5? -7. So x equals 1, y equals -7, so that would be our vertex at -1, 7. So go ahead and graph that. Sorry, I just put -1. It's +1. 1, 7, not -1. 1, -7. All right, so 1, -7 is our vertex. Now, today in the packet, we're going to use factoring on most of them to find, but I also wanted to show you guys, because I know factoring is still challenging for you guys, and since leap testing for some of you is tomorrow, I wanted to show you another strategy if factoring is something you forget, or just not every equation is factorable. So create a 3-column table, make the middle column bigger, and then we'll have x, that first column, and then we're going to use the formula 2x squared minus 4x minus 5, and then y. So another method is you could just plug in x values, solve the equation like we did over here, evaluate it, and then you can find your y values. So this is another method if for some reason you can't factor or you forget how to factor. So we already found x equals 1. So you don't want to choose any numbers too far away from that, because right now our graph only goes up to 10. So let's start with the numbers like right next to 1. So let's start with, let's do -1 to include a negative. So we're going to substitute or evaluate -1. So 2 times -1 squared minus 4 times -1 minus 5. So go ahead and put that in your calculator and solve for that one. It should be +1. Because -1 squared is 1. 1 times 2 is 2. And then -4 times -1 is 4. So 2 plus 4 is 6. And then 6 minus 5 would be 1. All right, so then we would put a point at -1, 1. Now, something else to point out is, remember our axis of symmetry is this x value here. So I'm just going to like highlight through this vertical line. So everything's going to be equidistant from this. So like this one, if we went 2 to the left and then we went up 1, 2, 3, 4, 5, 6, 7, 8. So it would be the same thing on the opposite side. We would go 2 to the right and then it would be, so let's just test that out. Let's see what it would be at 3. So, because right now, by just following that rule, going the same direction on the opposite side, because remember it creates a mirror image on both sides, let's see if 3 would also have a y value of 1. So do 2 times 3 squared minus 4 times 3 minus 5. What'd you get for that one? Yep, so again, it's a mirror image on both sides. So once you find one point, then if you count the same distance, like if you notice this axis of symmetry, if I go left 2, that's where the -1, 1 is, and then if I go right 2, that's where the 3, 1 is. Can you just open it because they don't know that? And then let's try another set. So let's find at +1.
These are all for you.
Awesome, thank you.
Thank you.
All right, let's do just a couple more sets. So at 1, so let's plug in 2 times 1 squared minus 4 times 1 minus 5. All right, go ahead and solve for that one. What did you get for that one? 97. And that was also our vertex, but that was another point. And then what's one more number close to -1, 3, and 1? 2. Let's do 2. All right. 2 times 2 squared minus 4 times 2 minus 5. What did you get for that one? -5, so 2, -5. And then if we know it's 2, -5, what would be the mirror image on the other side? If it's 1 to the right, what would be the ordered pair on the opposite side of it? But it's only 1 to the right. -2 would be 3 to the left. It would be at 0, -7. So mirror image has to be the same distance. So if we went 1 to the right, it would be 1 to the left. So that means 0, -7 would be another point. All right, then we can create our parabola. So do your best to connect all your points with that U-shaped line. And that is our graph. So that's just another method to graph. Find some x values, plug them in, find the mirror image on the opposite side.